Okay, guys, we have the second part of the chapter number 6, the part 2 of chapter number 6, talking about vector autoregressive modeling. And again, this part of it is a second part after the first part actually emphasized on the VAR reserve, and I show to you how to estimate that using EView easily. Now we continue on with second part, which is related to another new things for most of you, which is called Johansson and Jussieu's co-integration test. This actually built upon the idea of VAR by Christopher Sims, and then surely the model extended into the VAR kind of setting. From co-integration is not a new concept. It's been explained well in the previous chapter. It's actually developed by Granger, right? Granger itself, and then the famous article was Engel and Granger 1987, has been shown in chapter number 5. So here, following this idea, we have what we call as multivariate co-integration test, or Johansson-Jussieu's 1990. In short, it's called JJ. This again is built upon the var. Var itself actually assume that the variables are endogenous. All the variables are endogenous, means that if you change the variable, in other words, if you realize that later on I'll show you, if or even in the var actually, previously when we do our OLS or single equation, is that the first variable that we choose in EViews will be the dependent variable. But here, it doesn't matter which one do you choose at first, the result will be the same. The result of the Johansson-Jussieu will be the same, the result of the var will be the same, because var itself is a unique kind of solution which assume every variable are the same. There's no endogenous, exogenous, it's all endogenous. You have to determine later in the VECM, in the causality, in the variance decomposition, and other methodology to test the endogeneity of the variable, to test whether the variable is endogenous or exogenous. But for time being, the modeling process of determining whether the variable is endogenous, exogenous is not so much of the concern. As of this chapter, we are talking about this section, we're talking about co-integration tests. All right, let's move on. So this is the equation that assume that it's a vector with I1 variable, right, of an I1 variable, assuming that this is the vector of the I1 variable. Yes, Johansson-Jussieu can take into consideration of I0, I1 too, means that the mixture of integration. Right, we'll move to the next slide. So the advantage of the JJ test, in short, compared to the EG test, is because the EG test has 2 steps, and then numbers of articles actually have put forward to address the advantage for Johansson-Jussieu. For example, Phillips 1991, Chung and Lai 1993, and Gonzalo 1994. It's built upon var. EG is built upon single equation, so means that EG has numbers of limitation because it's single equation. I have to repeat, single equation. All right. So these are the two two tests that developed by Johansson and Jussieu. All right. Do not suffer for normalization problem, robust from departure from normality, is in terms of desirability, in terms of symmetry, unbiasedness, and efficiency. So it's much better than the EG test. So there's 2 tests inside there. One is called likelihood ratio, or the TRES test. The other one is called maximum eigenvalue test. All right. Both have to fulfill the requirement so that to address or to ensure that the Johansson-Jussieu test is fulfilled, whether it's co-integrated or not. Both of the tests, normally we look at both of the tests. All right, so the thing is that they are also very much related. This is a very important article. Rensel and An talks about small sample correction factor, where in other words that we look into whether when we have a small sample, for example, you have a very small sample which is less than 30, or maybe even less than 40 not considered a small sample, depending on what we are looking at, right? So this is the this is actually the right. Let me draw something here, right? This is actually the formula that you should remember in terms of test statistics, but to know whether to adjust for the small sample correction factor, right? Because the normal, if we have a very small sample, if you have a 40 or less, or maybe you have 30, right, you can use this method. I'll show you again this method, certainly inside the simple using simple EViews in a while. All right, so the criteria there, important implication of the JJ test. Case 1, very clear, full rank. I will show you some few variants of the result. Full rank. Case 2, the rank is 0, means that there's no co-indicating relationship, very clear. Case 1 here also very clear, is full rank, means that the variable actually are I0, right? Case 3 is when the reduced rank, and therefore you have a co-indicating relationship depending on the variables that you have, right? And this has been cited by in Harris and Solis 2003, says that the Johansson usefulness test can handle I0, I1, but I2 we either can replace with I1 alternative, or we do some different approach as suggested by Johansson 1995 for the I2 variable. But this is not the ideal condition for this chapter, right? Normally we have I0, I1, not I2, although some of the variable might be able to get I2, or some of the variable characteristic is I2. So again, let me show you these slides first, and then I'll show you the EView side. We use the same data, GDP, government expenditure with government revenue. Select the 3, open as a group. This thing will pop up, right? Open as a group, example, very simple one. And then go view, co-integration tests. We have the option there. We can choose number 3, allow linear and deterministic trend, or actually this is the default setting by the by EViews itself, and then you just click OK, yeah, and then we will come out the result something like this. So this result here shows a very interesting thing. I will explain it later, what the result indicate, how to interpret this result, right? Compare with this, you have one result here, you see it's the lag here, lag 2, right? Second result here, lag 2, but different result, and this different result and this 4 result. Why I put 4 result? Because here we have 4 case, 4 case in that sense, because here you can have more than one example. Case number 3. Why I'm saying that, again, I will repeat this thing back, right, for a while. Let just bear with me for a while. So 4 results here, I'll show to you all the 4 results, right? I will show to you all the 4 results using the simple test of EViews, right? Let me see how long already the recording. 8 minutes, right? 8 minutes, no problem. Let me go to EView. Wow, full. So this is based on University Malaysia Sarawak, and then let me go back. Yes, this example here. No, for now. Okay, so what you need to do, let me make this thing a little bit bigger. What you need to do first is that choose the variable. Choose the variables, right? In this case, we have L GDP, L EXPN, and L revenue. And then you open as a group, right? Open as a group. It's okay. Open as a group. Okay, open as a group, and then we go for view. Choose co-integration. Here again, because this is a latest version compared to my slide just now, you have 2. Single equation is the angle grandeur. Now you choose Johansson system co-integration test. So you see here, actually the default one is actually option number 3, right? Choose default. Right, here for the purpose for this one, I'll choose select 2, right? I'll choose select number 2 in that particular sense to show you the result, right? I choose select 2, produce the same result as the slide just now, right? Number 3 there, select 2, select 2, option 3, default. Result will come out as per my slides. Yeah. So this is actually case number. Following my slide, this is actually case number. This is the result for case number. For case number 3, right? For case number 3. So the idea here is that now we have 3 variables. Right, you have 3 variables. You have 3 variable, maximum co-integrating vector or relationship is 3. Maximum is 3. Minimum is 0. So you have 0 to 3. That's why you have that's why I show you 4 result. All right, and this one is correspond to all the cases that they are. In this case right now is case number 3. What is case number 3? I will explain to you right now. Very simple one right now. So this one, if you see this result carefully, what we need to interpret is only this part, these 2 parts here, right? The one that I highlighted here in blue color. You only have to explain these 2 parts is because the idea was to know what is going on here. So in this case, the null hypothesis is none. You see the null hypothesis there. See the null. Number 5, right? Null hypothesis is none. So if you reject, will be r equals 1, right? If normally that's how we write it. R means that it's co-integrating vector, and then the second one there, at most 1, at most 2, none, at most 1, at most 2 means that r equal smaller than or equal 1, right? If we reject, is r equal 2, right? This part might get a little bit confused, but this is how it works here. All right, you can repeat this video numbers of times. And the next one is r less than or equal 2, and then if reject is r equals 3. So maximum is 3, minimum is 0, is none, right? Again, minimum is 0, which is none, and maximum is 3. So you have 4 possibility of result, right? 4 possibility of result. Why 4 possibilities? Because you either can get 0, 1, 2, 3, 4. No, not 4. 0, 1, 2, 3 only, not 4. Sorry. If you have 4 variables, then you get 4. Right? 5 variables, you get 5, up to 5 here. So it depending on the variable that you have. So do not be confused on that. You have to do this one more time again. But yes, but we'll try to do that. Listen to this video. If you have any problem with that, let me know so that I can repeat it over and over again. All right. So now the result is that our result here, the result shows that the first is none, been rejected. Why been rejected? Because there is a star there. The star denotes rejection at 5%. If you see the statistic, then you know this one compare with this one, and you see the probability. The second one, right, rejected. So you confirm r equal to 1, but not yet finished. Don't stop there. So you should go for the second one, at most 1, and then you see the result. This is smaller than this one. The probability of smaller than 0.05. So do not reject the second one. Third one also do not reject. So we confirm for this result r equal to 1. R equal to 1 means that there is one co-integrating vector. Or translated into more simple language, one long run relationship. Alright? One long run relationship is easy, means that all the three variables moving towards the same equilibrium. This is the concept applied in economics. Right? So we talk about equilibrium, where you can draw the demand and supply equilibrium or any of the equilibrium. Then the three variables means that there's one co-integrating vector, one long run relationship means that one equilibrium only, right? Let me show you if we have if we have two vector, right? Let me change this restriction here. Right? Let me change something here to show you, just for the purpose of this, right? To show you the result. Right? Okay, I have this with me. Right? See, ta-da! Now the new result with this option, none is rejected, and at most one also rejected, means that we settle with R equals 2, right? Equals 2. All right. So in that sense, this will be the idea here, right? This will be the idea here. Okay, so R equal to 2 here, R equal to 2, in this case R equal to 2. R equal to 2 means that two co-integrating vector, 2, right? Here I copy so that I do not R equal to 2, so there's 2 here. Two co-integrating vector, two long run relationship. That sounds a bit confusing here. towards the two equilibrium. Two equilibrium now, two equilibrium, right? Sounds a bit confusing. So, and then the third result, this is second result. The third result that I can show to you, I think is this one. Yeah, the third result here, yeah, voila. The third result here shows that the none, the at most 1 at most 2, are all rejected. Oh, how do I put this thing back? Hiya. The most, you know, at none here, and all the 3 here actually been rejected, right? So none, at most 1, and at most 2 reject. So here, now we have 3 co-integrating vector, 3 co-integrating vector, 3 long run, and for 3 variable to 3 variable, 3 equilibrium. That sounds a bit more confusing. That is when is this case, right? Go back here. Just now the first example is the case here, case number 3. The second example also case 3. The third example is actually this one, full rank. We call it full rank because 3 variable, 3 long run relationship. So full rank, case 1. Right, so we have case 1, case 3. Now I want to show you case number 2. For case number 2, easy. Case number 2, I'll change back to leg 1. Let me have I'll change back to leg 1. Right. I'll change back to leg number 1, and then I will choose this. Alright, so this is case number 2. Now we have case number 2. Why we have case number 2? Is because if you see here, none of these are rejected. None not rejected, at most 1 not rejected, because all the probability and all the calculated statistic is smaller than for both cases. So case 1, case 2 here, sorry. Case 2, all not rejected. No long run relationship. Okay? No long run relationship, no coordinating vector, no equilibrium. Clear, very clear. Alright, so this is the 4 cases there for the 3 variable. Right, so I think that's all for now for the 20 minutes. If you have any question, I'll upload this in my YouTube channel, and subscribe to my YouTube channel also, and also I'll share that in Ellipse. For time being, thank you very much for listening, and if any question, you can always post that inside the group, or anywhere that's relevant. For time being, yes, fascinating, awesome, rather confused still, yes. Remember this part, remember this simple test. This is just one part of it. We can go further. Yeah, I want to show you one thing just now. I forget to show you this thing. Let me do this thing another time. Let me delete this thing first. Yeah, let me close this thing. No problem one. Let's see. I choose this one. Right? I choose like this, right? Rather than choose LGDP first. Right? Let me run co-integration test. If you realize that actually, the result just now, it's actually the same result. Even the statistics are the same. It's still the same thing, although I changed the sequence of the variable. Okay, you can try for the others. You can try with your own data. Right, for time being, thank you very much, and adios.